Hello, Reg viewers, and some new Regcast viewers, we hope, because this is a very exciting time for us. This is our first Reg hands-on. Now, you know we always say when we do our Regcasts, tell us what you want and we will provide it for you. Well, you did. You told us that what you wanted was for us to go deeper into the technology, to really explain how it works and demonstrate it. That's exactly what we're going to do for you in the next hour. I say we. I'm not going to be doing any of that. I'm just going to be looking on admiringly, and I'll introduce you to our new expert in a moment. But first of all, I have to tell you a little bit about the interface, the box that you're watching it in today. Another great innovation from the register today. We're in HD, which is amazing. You can watch it in full screen if you want. And so when we get to the demos and some of the more complicated stuff, you might want to do that. Also, there's buttons at the top, and you'll notice that you can ask questions still. So I'm sure that many of you will have questions, and we will try to answer as many of those questions as possible, get to the other ones afterwards if we feel that there's stuff that we haven't covered, see how it goes. But if there's something on your mind, ask the question, and we'll probably be able to explain it. There's another box that says poll question, another great innovation from the register. It's all innovations today. Another great innovation from the register, because for our next hands-on, you get to decide what it's about. So you can answer that poll question any time that you want. Go there and do it. It will remain live after we finish broadcasting. Tell us what you want, and the next hands-on will be what you choose, what the Reg audience votes for. You can download the deck and sort of make notes on that, as usual. And you see that there's some special offers. There are some training programs that we'll explain about later on, but you can get information of those. But let's get to the important person on this Regcast. I would like to introduce you to our new guest and welcome Paul Gregory. Paul, hello.
Hi, good morning.
Now, Paul, you do this all the time. It's going to be easy for you this next hour. This is what you do for a living, isn't it?
It is, but the presentation element, yes, that's going to be nice and straightforward. But obviously, always with live demonstrations, there are so many variables. Who knows what could happen?
Nothing could go wrong. Nothing could go wrong at all. It will be fine, Paul. No pressure or anything. But we also have, we've got loads of you tuning in for the first time today, which is terrific. Catch up with our other Regcasts and certainly watch more of the live ones. But also we have Trevor Pott, our house geek at the Reg. He's promised to get up in the middle of the night in Canada to go watch this. Hello, Trevor. And again, I want good questions from you, Trevor, today. This is the sort of thing that you regularly teach to sort of like a small classroom of people at QA, isn't it? This type of thing. Been a lot of interest in this sort of subject?
Yes, certainly. It's something we do all the time. Constant demand for this type of subject. Obviously, as always with Microsoft Technologies, as we all know, it sort of has a lion's share of the market. So therefore, there's always great demand for any innovative way to discuss the technology, whether it be classroom training or events like this.
Well, let's get on and do it. So I'm going to let you go free. Normally, I like to be in control of this thing, so this will be difficult for me because I have no control. I'm just the man who's looking at the questions. So you get on. You get on and do it, and I will hopefully put the questions in at the right time and not interrupt you and make you lose your train of thought. So yeah, on with HyperV 3 virtual machine movement. What are we going to cover today?
Okay, well, hopefully the idea is to look at the innovations around the ability to move virtual machines around an estate. And really, a lot of things have changed in that area. So one of the key drivers here, which gives us capability that the marketing people have been telling us we could do for 4 or 5 years, is actually innovations around the networking. So we're going to look at the networking, specifically focusing on virtualization of networking, and then get into the technical demonstrations and talk about virtual machine movement itself.
Good.
So just to expand on really what we're going to talk about from a networking point of view, we're not going to get bogged down in all the networking details of HyperV because it has actually completely changed in version 3 from previous releases. But really what we're going to focus on is on the virtualization element. But we do want to introduce where there are new features.
Mm-hmm. There's quite a big list of new features we got.
There is, and Microsoft have put a lot of work in here because their switch in the past was very basic. So now they've actually really addressed large customer needs and really sort of made it comparable with other players in the marketplace, obviously specifically VMware. So we've got everything from bandwidth management through to support for elements like data center TCP, spoofing protections, guard protections, and so on.
There's a couple of things on this that I'm looking down the list. I don't know about ENC marking support.
Yes, ENC marking support might not be something that a lot of people are necessarily directly familiar with. With the TCP/IP networking protocol, it's always had a congestion mechanism. So effectively, if too much data is being transmitted, the systems can effectively stop transmitting. Effectively, it was a fairly blunt type approach. The network's congested, I'll just stop and I won't send any more data, and I'll pause for a period of time and then try again. So there was no intelligence in the system. So ENC marking, or what's known as explicit congestion negotiation marking, is actually for the system to make some intelligent decisions about the actual way the traffic's being transmitted on the network, and actually smooth over the peaks and trough of network transmission. It is a technology used in the data center and actually requires additional technology over and above your operating system. So switches and routers, for example, would need to support this as well. But it's one of the new innovations in networking generally.
So who's that going to be relevant for, especially?
Well, I say it's going to be for your large data center customers predominantly, that are actually having those sort of network congestion type issues, trying to service large numbers of customers or users from within their estate.
Also interested, DHCP router guard.
Yeah, DHCP router guards are an interesting sort of set of features. The idea here is if you are going to start to look at services like self-service, so effectively you're going to have people provisioning and managing machines which are not necessarily controlled by the data center administrator. There's obviously a possibility people could set servers up as DHCP servers, for example, or set servers up as routers, and you don't want them to perform that. So DHCP router guard is a technology HyperV has to detect that if a machine is behaving that way and effectively block it from carrying out those actions. So it's a way the data center administrator can protect that environment.
I mean, it's a big change on that we have with Hyper-V. Like you say, it's a complete rewrite. Generally speaking, they've done a good job?
I think, ultimately it's a product there that stands sort of shoulders with the other vendors, so it's a real choice, and I think that's the driver there. Before we could have made excuses about it was good enough. Now it's a choice, and I think that's the key thing.
Okay, great. Now, if you have it, remember, keep those sort of questions coming in. We did just say that it would. There is a question saying that we did say this would change broadcasting forever, and we stand by that, Corey. It is our hands-on will change broadcasting forever. Stick with it and answer, and you will see when we get to the live demonstrations how exciting this is.
Yes, pressure.
Okay, right. So let's have a look.
Okay, so as I believe one of the requirements from the register viewers has been a case of being able to go in deeper to the technology.
You're going to take us quite deep now, aren't you? I've seen your slides.
Yes, we're going deep now, really because one of the things that the virtualization vendors have told us about for years is being able to build hybrid clouds, being able to burst to the cloud. And actually, those technologies provide lots of challenges. If you want to take a virtual machine from your data center and migrate it to a hoster, that presents massive challenges. If you've got two data centers and you want to migrate virtual machines between the data centers, it provides great challenges because you've either got to do complex things like have stretch VLANs, and VLAN management is massively difficult, or you've actually got to deal with some downtime because of changing IP addresses and all those bits to allow virtual machines to carry on working. So network virtualization is going to do for us at the networking level, which virtualization did for us at the actual operating system level. So it's going to allow us to run virtual machines with IP addresses which don't necessarily represent the network that they're physically connected to through the machine. And effectively we have address translation tables which will actually allow us to be able to discover and connect to virtual machines wherever they might be. So based on the sort of slide that I brought up, you can see we've just got this sort of concept of virtual machines from different organizations actually being able to be consolidated onto the same network infrastructure without actually having to worry about IP address information. So this sort of model here would be a great model, say for where two organizations merge, or an organization buys another organization out, and you want to consolidate the data center. In the past, there's been massive amounts of downtime because of all the IP address reconfiguration happen and all those tasks that need to happen. This would provide a mechanism to sort of eradicate those types of problems. And it really gives us this true mobility, which is really sort of where we're going.
Which is a fundamental part of when I sit here normally and I hear people talking about how the data center of the future will be flexible and it will allow us to be able to do things like this. This is really the hard work that has to go into it.
It is. And going really back to that sort of scenario, looking at the slide that we've got here, we've got two organisations, one Blue Corp, second one Red Corp, and we're going to keep with those names and these IP addresses so that the slides actually make some sense as we go through. So you can see Blue organisation has machines with a couple of IP addresses. Red organisation happens to have a couple of virtual machines. Again, with the same IP addresses, they use the same IP address structure as this other organisation. So from the point of view of, say, for example, consolidating their data centres or even maybe being able to move to a hoster, in order to maintain connectivity to their applications all the time and without having to change IP addresses, there would be a whole load of barriers. So effectively, what we call a virtualization policy allows us to actually build rules which allow us to map the IP addresses from the actual virtual machine to the IP addresses of the physical computers where they're going to run to. So in this case, for example, inside the hoster. And the key real driver here is one of the things that's really good about this technology is it actually allows us to even have IP address conflicts, or what we would perceive to be IP address conflicts. So we can actually see, for example, in the example in the slide, on host 1 on the left, it actually got the virtual machine from Blue Corp and the virtual machine from Red Corp on the same machine, and they have the same IP address. But actually, Blue Corp can talk to theirs and Red Corp can talk to theirs, so we keep the traffic isolated. Okay. Now this isolation is actually done because of some additional information, which is basically so we'll have a look at in a moment. But really, the key thing we want to look at here is, from an IP address point of view, we have two pieces of information. We have what we call the customer address, so that identifies the IP addresses that the customer is using, the virtual machines are actually using. And then we actually have the provider address. So this is actually the IP addresses on the real network that the computers are actually connected to. Now, we'll notice in the slide it does talk about System Center. There is no requirement for Microsoft System Center to achieve this, other than, as always with the System Center products, they enable. So effectively they make the experience easier, seamless, and far more transparent, whereas without System Center, there's a bit more work to do. You've got to be good at scripting. So how does this actually work? So what would we actually see and what would be going on inside HyperV to allow connectivity from one virtual machine to another virtual machine in the same organisation? So here we've got two machines. Now, it happens that these two machines, if we look at the IP addresses at the bottom, are actually on the same network. It doesn't matter if they're on the same IP network, different IP subnets, different geographical locations. The principles would still be the same. So I want to get a message from the virtual machine known as Blue 1, and it wants to send some data to the virtual machine that's Blue 2. So we could, let's say, for example, say Blue 1 is a web server, Blue 2 is a back-end SQL database that it needs to retrieve some data from. The key driver on here, you'll notice we've got this VSID, Virtual Subnet ID. This is effectively a customer code. So this will identify a set of computers that are allowed to communicate with each other. So in a hoster scenario, they might allocate one of these per customer. If you was going to sort of be merging data centers, you might actually have several within your data center to represent where the virtual machines originally come from, maybe the part of the business. So the idea here is, if we think about the traditional way an IP address message gets transmitted across the network, we have a source IP address and a destination IP address. So effectively, we want the message to go from IP address 10.0.0.5 across to 10.0.0.7. When we actually send messages across the network, obviously what we need to do is actually, first of all, on the front of the message, put MAC addresses. So the Media Access Control address. So effectively, again, we've got the MAC address from machine Blue 1 and the destination MAC address of machine Blue 2. So that's really, as far as the virtual machines are concerned, that's the message they transmit. So that obviously goes into Hyper-V. So effectively, inside the Hyper-V switch, we have that same data, but the Hyper-V switch also then realises, because this has come from machine Blue 1, it understands which virtual subnet ID it's come from. So it goes, that is virtual subnet ID, in this case 5001. So the virtual switch actually passes it on to a component called the network virtualization filter. And the network virtualization filter in HyperV is responsible for looking at a mappings table, and it will actually look at the virtual subnet ID, the source IP address, and the customer IP address, and that will allow it to define how it's actually going to get this message out of the physical computer and onto the destination machine. So the key thing in the mapping table is it will actually tell the HyperV server that IP address 10.0.0.7 is actually on physical host 192.168.4.22. So that what we'll actually see across the network, and I appreciate this is a little bit small, but we'll actually have...
This is where the full screen's useful.
Exactly, yes, definitely. So actually, the actual packet that traverses along the wire will actually have the source MAC address from the computer system on the left, so whatever that MAC address is. It will have the destination MAC address of the computer system on the right, because they're on the same subnet. Obviously, if it was going via a router, it would have the MAC address of the router. And then we've got the source IP address and destination IP addresses, again, of the physical machines. So therefore, that allows it to be routed across your physical network. And then as a separate set of information, we've actually got the IP header that's going to be passed into the virtual machine. And you'll see there, right there in the middle, is the virtual subnet ID, a little bit like a VLAN tag. So similar concept in how we're doing this, but we've got this extra layer going on. So that message now traverses the physical network in the same that any normal IP address network message would. So what happens at the other end? Well, we're now getting to the point that we're going to receive the message. So obviously the receiving system receives the whole message as we would expect. So the first thing it would do is it would actually take off the header that's been used to get it across the physical network. So what we actually end up with is now the source MAC address from Blue 1, the destination MAC address of Blue 2, and again the source and destination IP address. But we've still got, obviously, this virtual subnet ID attached to it of 5001. So effectively that tells the network virtualization filter how to pass this up into the HyperV switch, and therefore where the HyperV switch actually sends this information. So this will actually then lead up into the HyperV switch. So we've actually now got just a standard message that we're going to pass into the virtual machine, no different if we wasn't using network virtualization. So therefore, the virtual machine just receives the message and it interacts with the data just as it normally would do. And then obviously when it wants to reply back, it's the complete reverse of the process. So the key element here really in terms of this process is these mapping tables. So the mapping tables by default are maintained on HyperV servers. The mapping engine that we're actually using does support a gateway system, so that's built into the solution from Microsoft. So you could use a dedicated Windows Server 2012 machine, which would be the reference point, so all the systems would refer to that point to be able to do the lookups. There's also, most of the majority of the network vendors are getting on board with this technology. So you would actually be able to use things like, for example, like a top-of-rack switch to actually host the mappings table for you as well. So you can actually offload it from the actual virtualization systems. And one of the great things, again, with the System Center integration is as the vendors are developing support for this in their switches, they will also develop packs to fit inside System Center. So System Center will manage all the configuration inside the switch and all the mapping table for you. So again, it will be completely transparent. So what I've described here is, from a network virtualization point of view, is what Microsoft is basically referring to as NVGRE, which is a draft standard. So the network virtualization, generic routing and encapsulation protocol. So this technology, as I'm sure all of the tech-savvy viewers can see, has an overhead. So one of the things to consider from the point of view of real-world implementations is this technology is more likely fine in scenarios where we've got 1 gigabit Ethernet, those sort of bits. There is actually a second technology from Microsoft for organisations that need either the sort of highest level of throughput or actually looking at 10 gigabit Ethernet and above, maybe InfiniBand networks and so on. And they have a second network virtualization platform, which we're not going to talk about here, called IP Rewrite. It works in a similar mechanism, but it actually changes the header information. So rather than append a new header, it actually modifies the existing one. The one thing with the two technologies, which is quite important, effectively NVGRE will work on anybody's network today. You don't need to go and buy any specialist hardware or anything along those lines. But IP rewrite, again, will need some vendor support from your networking vendor.
Well, specifically, what kind of vendor support are going to be needing?
Well, effectively, because we're going to change the way some of the header works, the switches and the routers in there will actually have to support IP rewrite.
Yep.
So that's what they're going to need.
Do you want to answer some questions?
Okay, see what we've got.
We've got, basically, kind of, first of all, simple question. What sort of overhead is this adding?
Like a lot of these things, it partly depends on the size of your mapping tables and so on. So, it could be anything from, sub 1% maybe to 3 or 4%, depending on the size of the tables, really.
Okay. So, so how many VSIDs can you have?
It's an incredibly large number. It's 16 odd million off the top of my head, but I can't remember.
It's an incredibly large number.
Yes,
We'll settle for that.
Yes, I can't remember the actual exact number.
How do these VSIDs differ from port groups, VLANs in the vSphere?
Well, I guess ultimately, if you wanted to sort of align it to VMware technology, we'd be talking about VXLAN would be their variant of this technology. Mm-hmm. So effectively, this is a complete alternative to VLANs. Effectively, in Hyper-V, we still have VLANs, and if you want to do VLANs, you can, the same way as you would do in VMware. Mm-hmm. But effectively, as already touched on, VLANs have a scalability limit. You can only have 4,994 or 95 of them, and they're very hard to manage.
Okay. How difficult? That's the migration questions now. So people looking at to have legacy Hyper-V.
Okay.
If you're going to migrate these to the Hyper-V 3, how difficult is that migration going to be? That's quite a big question.
Okay. Yeah, it is a question, and obviously the migration's actually relatively simple. Like everything, sometimes it comes down to how much money you've got. So what a state do you have? So, for example, if you're not really worried about downtime and you want to sort of minimise the cost as much as possible, you can literally just export virtual machines from version 2 and import them into version 3. But obviously, that's a whole downtime experience.
Yeah.
On the other hand, if you're a system center estate, you can actually migrate them from 2008 to 2012 using System Center Virtual Machine Manager. So it will automate the process for you. So it will be a bit easier from that point of view, but again, there's still downtime. Then you can actually move into looking at third-party support if downtime's an issue to you. And there'll be an interesting white paper coming out shortly of an organisation in Europe which actually migrated virtual machines from one virtualization platform to another. And obviously this principle would apply from Hyper-V to Hyper-V. And they managed to migrate some very large virtual machines, and actually in total over 3,000 of them. And the most any virtual machine was offline for was 15 minutes. So
that's quite a job, isn't it?
Yes,
that's you said there's a white paper coming out about
from
that.
Microsoft. Yes. So basically, it will be related to a company called Vision Solutions, who actually use the value add products. So some of you might be familiar with the sort of data replicator products that Vision Solutions has, and they used it to migrate data.
Okay, let's look out for that. We'll try and bring that for you, bring that to you when we locate it.
Yes,
we'll have a word with Microsoft afterwards. With the overhead, does it affect MTU?
Does it affect MTU? Obviously, it does, because the packet's getting bigger. So it does affect MTU, yes. So obviously you potentially have less data in each message if you've got small message sizes, so yes.
Good. And so again, question from Keith here. Let's try and get this right. The virtual switch is now layer 3 switch capable. It's layer 3 switch. Does it do layer 4 TCP redirection?
It doesn't do TCP redirection. No. Obviously, we've got this sort of TCP/IP interpretation stack, but it doesn't do TCP/IP redirection.
Okay. And yes, I'm just trying to make sure that I've covered all these. They're really coming in, so thank you very much.
Yes, excellent. Thank you.
This is good, isn't it? It's a good, terrific question. Okay, how do the NVGoE and IP rewrite technologies play with something like HP Virtual Connect for blade enclosures? Any specific considerations for east-west or inter-chassis traffic?
as far as I'm aware, and obviously you'd need to speak to HP of this. I don't know about HP.
They might be the very best people to ask about
absolutely.
this.
But in principle, it shouldn't have any problems. But you'd need to speak to HP, to be honest.
Yeah, it's obviously, yeah. And anything special about east-west traffic?
Certainly not that I'm aware of, no.
No. So, I mean, basically what you're saying here, it applies for everything. Yeah.
Yes. And effectively, any networking hardware, any networking infrastructure should work with NVGRE. Obviously, IP rewrite might be slightly different. So I wouldn't expect HP to have any problems. But you would need to consult with them to be 100% certain.
Do you want to do a couple more? The more we answer, the more they ask. We'll move on in a second,
okay.
But we can do a couple more. How would you attach a network device that's outside Hyper-V into a particular customer, i.e. a physical host that belongs to the Blue One customer?
I assume you're sort of referring to if for example, you was a hoster.
Yeah.
So effectively, in terms of the connection path, obviously you've got your Hyper-V systems that are running in your estate. You want to connect to a Hyper-V host outside of your estate. So obviously the mechanism there would be some form of site-to-site VPN. So therefore we would just see it as a normal IP-routed network into the hoster. So it would, providing we've got a normal IP-routed connection to it, that's all we need. So we don't need anything special when using NVGRE. One of the things that, again, for people that are really interested in that, there's actually a very good webcast on Microsoft's website actually showing how it would connect to a hoster specifically.
Aha. Right.
So therefore, systems outside.
Go to, yeah.
So go to
have a look at that
on the TechNet site, but not yet. Yes,
not for at least another half an hour. Okay, and there's the last one, and then I'll let you move on because we've got a lot of other stuff to do and your demo. What happens when the PC in this situation? What happens when the PC on the LAN pings 10.0.0.5? So which one does it get?
Okay, so effectively, what would actually happen is it would be routed into your data center. And effectively, by default, it would go to the Hyper-V host in your data center that last held it. Okay, it would then use its mappings table to forward that on. If you've obviously got the technology like I mentioned, that we can integrate this into top-of-rack switches, those sort of things, it can actually get interpreted by the switch before it reaches the Hyper-V host.
Okay, just to finish this little section off. So there's a couple of people asking, really on a more general thing, the pros and cons of this as opposed to VLANs.
Well, really, the problem you have with VLANs is first of all scalability. So for example, if I was a hoster to start with, by using VLANs, that directly limits the number of customers that I can have. So it limits me to the sort of 4,000 plus customers. Now, some hosters might turn around and say that's perfectly okay. But if we was to talk about, for example, someone like Fast Hosts, I'm sure they wouldn't want to limit themselves to 4,000 customers. So first of all, it removes that limitation. The second pro, if you're not sort of really considering it from a hoster's point of view, is it actually makes the internal network configuration much easier. I was actually on site at a customer recently, and we had a day and a half's of downtime because someone made some VLAN configuration changes to their network, and they made a mistake. And effectively, it took off large parts of their network, took it down. So this would completely eradicate that as a problem. So they're the sort of plus sides. Obviously, from a con side point of view, as was said, ultimately, there is an overhead. So effectively, you could have some data throughput reduction. Certainly, we're using the NVGRE, depending what the applications are. Ultimately, there is going to be some more traffic crossing your data center network, which maybe doesn't need to be there. So there is going to be a small traffic increase. But I think those downsides outweigh what the benefits are going to be.
Good. I'll let you get on with it. Thank you very much for that.
Excellent.
That was terrific. I'm firing everything at you. I'm trying to find the most difficult ones. Great. Let's move on because we want to get through all the material and make sure we've got plenty of time for you to see it working in real life.
Yeah. Well, you can always ask as many questions. Because I'm a typical instructor, I can always turn around and say, "I'll get back to you on that one."
Okay.
Okay. So. this is now going to get us into looking at the way Hyper-V free's changed from the ability to move virtual machines. And chances are, most of the things we're going to look at in here, I suspect most of you are going to be aware of as concept. Microsoft have talked about this a lot, but hopefully, maybe some of you haven't seen some of the things that we're going to do. So hopefully, actually prove to you that it works. Unfortunately, I don't have a big data center, so we're not going to be doing any network virtualization, but we'll get some machine movements going. So we're going to start off with, really because storage movement was quite a big component that was missing from previous versions of Hyper-V, and that really becomes a massive component. So we'll talk about storage movement and then sort of move into complete virtual machine movement. So first of all, storage movement, we did get from Microsoft in previous releases through Virtual Machine Manager in the ability to do what Microsoft sort of used to refer to as quick storage migration, which effectively allowed us to migrate the files that made up a virtual machine from one storage area to another, but the virtual machine was offline. So effectively, it made it easy to do, but there was downtime. So key drivers with the storage migration, or live storage migration if you'd like to call it, we can now move any of the files that make up a virtual machine from one location to another location. So this really allows you to address all sorts of scenarios. So you're running out of capacity in your LUN on your SAN, you need to move virtual machines off there, maybe for more capacity. You can move them without any downtime. Maybe you've got an old SAN and you put a new SAN in and you want to move resources across, so we can move them across again without any downtime. Plus, it also allows us to address elements like performance bottlenecks. So if there's too much activity going against one part of the storage, we can move parts or virtual machines off to the storage where we've got spare capacity. So these are the sorts of benefits, as well as obviously what we've been talking about already, like burst to the cloud and so on. Now, from a storage migration point of view, Windows effectively supports one of two storage migration mechanisms. The first mechanism is we can copy the data from one data store to another data store by crossing your network. So if you haven't got any posh storage, for example, expensive SANs, that might be your only option. Or maybe if you've got data that's on, for a virtual machine that's running on directly attached disk and you want to migrate that into a SAN, then that would be an option to achieve that. Obviously, the downside with that is it's slow. And it's got sort of quite an overhead on the systems while we're doing it. So one of the things we also support, and this is enabled in the box, so there's nothing that you need to do this, is we do actually support what's called offload data transfer. So the idea of offload data transfer is we can literally effectively instruct the storage to copy the data to maybe another LUN on the same storage, or even to another SAN if that's a requirement, and it will perform that copy internally. So it won't actually put any load on the actual Hyper-V host while that data transfer is actually occurring. And then effectively, once the files have been migrated across, there will be a token that will move so that the Hyper-V host knows where the storage is. And as part of this, and my slide's indicating to this, we could even be moving the virtual machine at exactly the same time. So we could be moving the virtual machine from one host to another as well at the same time.
Is that wise?
Well, it works perfectly well, so yeah, it's pretty safe.
So disk A is on one SAN, disk B is on another SAN. That's possible. That's
possible. The only requirement is, obviously, other than the SAN needs to support it in the first place, is the SANs have to be from the same vendor. Okay, and obviously the SAN vendor might put some restrictions in there as well. But effectively, we can't do it between SAN vendors. It definitely has to be the same SAN vendor today. Okay. So. Live migration's been around, obviously, since Windows Server 2008 R2 or Hyper-V version 2, if you'd like to call it. And this effectively allowed us to move a virtual machine from one Hyper-V host to another Hyper-V host with no downtime. So the system carried on running. And this has always been a model that's required shared storage. So effectively, the two hosts have to talk back to the same set of shared storage, so the same SAN. And again, this was one of the restrictions for some customers because the cost was expensive. Because your SAN effectively had to be block level storage. One of the key things that we now support is also the ability to actually live migrate virtual machines from one Hyper-V host to another Hyper-V host, now using the new server message message block storage. So we don't need to go and buy an expensive SAN. And one of the things that's really quite good with this, if you look at organisations like NetApp, for example, they actually have NAS appliances now supporting server message block free that you can do this with, and also take advantage of offload data transfer and move the files between shares and stuff as well. So there's a lot of capability appearing here. So just to really recap, and again, this is really, I'm sure a lot of people are going to be fairly familiar with this concept, in terms of actually how live migration works as a concept. So the idea being, if we want to move a virtual machine from one Hyper-V host to another Hyper-V host, we actually take a snapshot of the memory. So the virtual machine is running, and we take a copy of the memory. And the idea is we send that memory across the network to the other Hyper-V host. Once we've actually completed that, chances are where the virtual machine is running on the first Hyper-V host, memory's changed. So what we will do is we will go back and we'll do an iterative copy. So we'll have a look at the data that's changed, and we will copy any change data. And we'll keep going back until so little data is changed actually on the first virtual machine that we can actually then switch the virtual machine to be running on the second host. Mm-hmm. And as part of the measurements we're looking for that switch is the ability to be able to switch across within less than one TCP timeout. So from the user's point of view, there is no downtime, the machine did not appear to go offline. Obviously, when a lot of people demonstrate this, they often use sort of a ping type test. So we'll ping the virtual machine, and when you actually see the virtual machine move, you sometimes lose one ping. Depending on obviously load on the systems. So really from the live migration point of view, the key driver in actually how long it takes to get that virtual machine from computer A to computer B is obviously going to be directly related to how much memory the virtual machine has got and how busy is the virtual machine. So what's it doing? So what's the churn rate on the memory? Mm-hmm. So that's a fairly standard based process. So one of the things that we introduced with version 3 is being able to extend that, because we've had a lot of limitations in the Microsoft platform. And we can now actually move not just the virtual machine, as we've hinted at already, we can move the storage at the same time. So that allows us to actually do a whole load of things that we could never do before. So that allows us to move virtual machines from standalone hosts into clusters, move them between clusters, and a range of other activities, including sort of elements like burst to the cloud, as we've been sort of hinting at. So we can actually perform what's often referred to as shared nothing live migration. So the only thing the systems have in common is a rooted IP network between them. And that's hopefully what we're going to try and demonstrate and actually talk through, by going into the detail, the configuration behind actually how we set that up to actually achieve that. That's the plan.
That's the plan. This is our world first. Just quickly on this, what's the equivalent for VMware here again?
Right, okay, so yes, so VMware obviously have their vMotion technology, which is the ability to move virtual machines from one host to another, mm-hmm. and they also have their storage vMotion, which is their equivalent of the storage migration technology. So that would be the equivalent names in the VMware space.
Mm-hmm. And is it feature equivalent?
Fairly feature equivalent in terms of the virtual machine mobility. Certain things happen slightly differently, and obviously, VMware and Microsoft always have the sort of slightly different support caveats and what have you. Yeah. But ultimately, yes, fairly equivalent.
Well, let's see how it happens.
Okay, so what we're going to do here in the first demonstration is we're just going to go and set this up. Okay, so hopefully I'm going to connect across to my remote systems. So they're still online, which is obviously always a good start.
That's a relief. That's I'm happy now. Where is this remote system?
Well, it was in my living room, but it's in my dining room now. My wife's not been too happy about a pair of servers sitting in my living room.
Oh, she must have known about it when she married you. She's fine about it.
Well,
it's helping us.
It is.
Thank you very much. Now,
yes.
Let's. So explain. What do we have?
Okay, so effectively, what we have to start with is I have a pair of physical servers. So if I just go to the all servers section on the left, so we can see all the machines, I have a pair of physical servers called QA-HV01 and QA-HV02. So these are the machines that are actually running Hyper-V. I've also got a virtual machine, imaginatively called QA-DC01, so that's a domain controller supporting my Active Directory. And then I have a couple of other virtual machines. So I have one called QA-Zoo01, which is supporting my Zoo web application, okay. Which we'll obviously use as demonstrating that it's still running. Mm-hmm. And I have a second machine here, which is labelled as Demo 1, which is not actually one we're going to be using. That's just in preparation for something we might do later on. But at the moment, we're not going to be using that. So I guess really, just to show you, if I just go out and open up Internet Explorer, on that Zoom machine to start with, this is the website that's there. So obviously we can see the website's working, quite happy with it, no problems at all. So I'm just going to minimise that, and we'll come back to that once we're set up and we're going to start moving machines around. So I'm going to come down to the HyperV section on the left-hand side, and I'm going to go into the HyperV Manager, which I'm sure a lot of you will be familiar with. So you can see my 2 Hyper-V hosts. You can see that I've got my 3 virtual machines all sitting basically on host number 1 at this moment in time, and it's effectively going to be the sort of QA Zoo 01 machine is the one that I'm going to be moving and demonstrating with. So first and foremost, we have some setup work to do. Now I have already set up host number 2. There's certainly no fun watching me do the same setup twice. So sort of in the traditions of best cookery shows,
you prepared earlier. Exactly.
So what we'll do is we'll go through the QA, the configuration on host 01. Now, some of the settings I'm going to go through quite quickly, and then we've got a couple of screenshots we're going to go back to, because while it's migrating, again, there's only so much fun you can have watching a percentage gauge go up.
Yeah.
So we will come back to some of the settings in a bit more detail. So I'm going over to the right-hand side, and I've just launched the Hyper-V settings screen. So again, if you've not done much with version 3, the first thing you'll notice is there's a lot more stuff inside the Hyper-V console, and specifically there's a discussion about live migrations, because before you always needed the clustering engine. Now we don't need clustering to perform live migration, so it's all part of the Hyper-V management tool. So I'm just going to enable live migration, so basically allowing incoming and outgoing migrations. And you can see that I've got a choice of a couple of options in terms of the credentials security support provider, or by using Kerberos. Now effectively the Cred SSP option is the easy option to set up, but it has a couple of limitations, and effectively there's a significant limitation from a support and a usage point of view is you have to initiate the migrations from the physical computer you want to move the machine from. So in this instance, if I move my Zoom machine, I have to initiate it on host number 1. If I've then moved it to host 2, I would then have to initiate the move back from host 2. Okay? Whereas with Kerberos gives me a higher security level, but it also gives me the ability to initiate the migrations from anywhere, but it does require me to make some Active Directory changes. So once we've got this set up, we'll drill into what those Active Directory changes are as well, so you can see those things that have to have been done. So I'm going to choose Kerberos because I've got that set up. Now, one of the questions that's often asked is, how many migrations can be performed at one time? And in the old product, it was effectively a host could only be involved in a single migration. Now, effectively, there's no limit. You can actually have a host sending or receiving as many machines as you want. Obviously, there might be practical limitations for capacity, performance, and so on. So, again, you wouldn't necessarily put large numbers in there, but certainly, concurrent machine migration is supported. So I'm just going to leave this set to the default of 2. The other thing which is often regarded as a best practice is you can actually go and configure what we call live migration networks. So live migration networks allow us to actually route the migration traffic on a specific IP subnet. So the idea being we don't route it across our production network and have any production level impact. So again, just trying to improve it. And obviously that gives us not only the benefit from a production point of view, it also would normally mean migrations are going to be faster because they've got a dedicated network linked to themselves. So I'm fortunate enough to have a dedicated live migration network. So all I'm going to go to the add box, and I'm actually just going to put in the IP subnet address for the actual live migration network. So we just put the IP subnet in, and it's subnet mask. Now, one thing just to watch out for in terms of this technology is if you do put a live migration network in, again, from the point of view of high availability, you either want to make sure you've got team network adapters or you put multiple subnets in there. So obviously make sure that you do leave some room for that high availability. If I wanted to, I could also add my production network in there, and you'll see that when you've got multiple entries in the box, there's the up and down buttons, which are sort of greyed out because I've only got one entry. So I could prioritise the network, so we'll fall over onto the production network if the live migration network's unavailable as well. So that's the setup, and obviously we need to talk about that Kerberos option a little bit more. So I've actually gone and made those same changes, and just obviously I'm not going to make any changes, but just to show you, if I go to machine number 2 and just go to the Hyper-V settings, we will see exactly the same configuration at that end. Yep. Okay. So what we're going to do is migrate the machine using the graphical interface to start with. So again, those that would have used version 2 would have been used to doing this in the clustering engine. You can still do it in the clustering engine if it's a cluster, but I can now actually migrate straight from the HyperV Manager. So I can right click on the virtual machine and I can then specify where I'd like to migrate it to. Now the thing that's important about my environment is I have no central storage. So effectively I have a pair of rack mount servers sitting on my dining room table, and there is no central storage between them. They've only got directly attached disk. So as part of this, the wizard's actually going to detect that, and it's actually going to realise it's going to have to move the storage as well and keep the systems online while it's performing the move. So I'm going to say, obviously, I want to move the virtual machine. You can see there is an option just purely to move the storage if that's what I wanted to do. I don't have any shared storage, so that would make no sense to me. And I then get asked, obviously, where would I like to actually send it? So I'm going to send it to my host number 2, so QA-HV-02. Mm-hmm. I then basically get asked about how do I want to move the storage. So the VHD files, a virtual machine could be made up of multiple VHD files. So I can choose to move them all to a single location, which is what I'm going to do. I could also choose to actually be selective, so I could actually choose to move different VHD files to different locations. Or again, there is actually an option that says just move the virtual machine, which obviously won't work for me because I have no shared storage. So then hopefully we press next, and I then get to specify where I'd like it to go. So if I press the browse button here, what you'll notice is this has actually connected me across to the other host. So I'm looking at the file systems on the other host. It's not on my local machine. So I'm actually going to go and move this into my production VM folder, okay? And I'm actually just going to move it into the sort of QA-Zoo folder, okay? So just be aware on the destination box, if you actually specified a top-level folder, it doesn't create subfolders for each virtual machine. So that's something to watch out for, just from a real-world point of view.
Otherwise, you're going to make a terrible mess.
Yeah, absolutely. All your virtual machines are going to get intermingled, which obviously catches a lot of people out. So you do need to make sure you've got a subfolder for each machine. Mm-hmm. So then hopefully we're at the end. So obviously we just get the summary page, and you can see it's going to tell me where it's going to move all the individual objects. And then I can just hopefully press finish, and it will then go and initiate the move. Now, the system said we could do multiple machine moves, and some people have said to me, oh, you can't do multiple machine moves because the box doesn't disappear while it's moving. Okay, well, you can because the box isn't modal, so effectively I can click back into here and I could initiate a second move if I wanted to.
First move's still going on.
First move's still going on.
Basically starting again, the box sits around in the background.
Absolutely. Yeah. So we can see now we've got the percentage of the migration that's going on, so it's 6%. Obviously, if I was to go and jump into here, we can actually see that my application is still perfectly happy. If I go and do something like a Control F5, again, just to do a full refresh to make sure there isn't any caching going on as far as the browser's concerned and so on, we can see that it's all working quite happily while that migration's going. So obviously going to take a little while because I haven't got any shared storage. We'll leave that running. So just while that's running, I'm just going to go across to look at the configuration of Active Directory. As I said I would, so I'm going to just go back to Server Manager, go into Active Directory Domain Services in the Server Manager tool and open up the Active Directory Using Computers. So if you want to use the Kerberos feature, which I'm using, what we have to do is we have to configure delegation. So we have to effectively allow the Hyper-V hosts to assume other credentials. So if I go into the QA-HV-01, and I would need to set this up on all my Hyper-V hosts, so I've done this again on both of them. If I go to the properties, I've got the delegation tab. So I've effectively set up a rule in here which actually effectively defines that on when we're sending information, when information is being sent to Hyper-V01, QA-HV-02 is allowed to impersonate for the file system object and for the Microsoft Virtual System Migration Service. So they're the two settings that need to be set up so that I can migrate from any Hyper-V console, basically. And again, I've done the same on the other host.
Quick question.
Okay.
Is Active Directory required to do live migration?
Ultimately, if you use Cred SSP, you can do live migration without it. Obviously, if you're going to have a cluster, you need Active Directory for that as well. But you can do it with Cred SSP without Active Directory.
Okay.
Okay, so that's hopefully sort of migrating in the background. I was going to go and talk about some other stuff, but we can actually see that the machine's actually now migrated across onto the other host, and it's all completed. So that happened fairly smoothly.
It's nice when it happens like
that. It does, yes.
Yeah.
And obviously my application is still working.
Lovely.
Okay, so there's a couple of things I'd just like to sort of expand on. So we just drop back to a couple of screenshots if we can. Yeah. So really, I think in reality talked about all the elements as far as the sort of settings box when we went through it. So I think we looked at, or talked about the CRED SSP and the Kerberos. And I was going to mention, obviously, we can get away without using Active Directory, but someone's preempted me with a great question.
Yep.
So that's good. So I think we've sort of covered that box now. So I just wanted to talk about what happened because I didn't have any shared storage, and actually how did the data, or how did it move from one location to another. So the idea basically was, obviously we got our Hyper-V host writing to our VHD. When we initiated the move, what actually happened is we started to copy the disk files onto the other host. When we got the two disk files in sync across the two computers, what was actually happening then, when people were interacting with the virtual machines, we actually wrote to both the disks concurrently. So the writes were actually occurring on both the disks. We then copied the memory over the same way as we talked about earlier on, and then transferred complete activity onto the other Hyper-V host. So that's how the without shared storage migration actually worked. So we initially copy the disk files across, we then write to both systems at the same time until we switch the virtual machine across. And that's how we have no interruption to service while we're migrating without any shared disk. So what I was going to do was I was going to go back to my demonstration slides
and see how it went,
but it went swimmingly well.
It finished early. Well, just before we get to this wrapping up, do you want to take some more questions as well?
If there's a couple more questions, yeah.
There's more than a couple more, to be honest. You'll be answering these the next week, Paul. I know that you have a schedule, but I'm afraid you will. Do you have someone's talking about do you actually have any other demos? I mean, not obviously, clearly not today, but for virtualized storage using sort of local disks on servers as opposed to SAN. That's something we're interested in for their internal dev clouds. Well,
so do you mean virtualized? Yeah. So obviously, I was using directly attached storage.
Yeah.
So it depends what you mean by virtualized storage. Do you mean sort of storage running inside virtual machines, or do you mean sort of virtual SANs? In a SAN appliance. So it depends. My email address will come up at the end. Feel free to email me with more details, and maybe we can talk about that one offline.
That's a good offer. And great. So how does the hypervisor's own CPU utilization on the physical hardware offered by Hyper-V plus Windows compare to the single stack hypervisor such as VMware? So that's
that's a really interesting question, and I guess ultimately, to a certain extent, there's a lot of marketing sort of involved in that, and I guess the first thing I just want to highlight is, I'm a VMware fan as well, so I don't want to, sort of say one way or the other. But I guess really, for my own personal experience, there was an interesting customer that I did some work for, migrating about 1,600 virtual machines, and they were on ESX4, and we actually migrated them to Hyper-V version 2, and at the end of the migration we was actually able to decommission 10% of the hardware because it wasn't needed where it was under VMware. So that's one real world, but as everything,
your mileage will vary.
Exactly, yes. Yeah, it depends what the workloads are and so on.
Yes. Is there, when you're doing the memory move of the VM from one Hyper-V server to another, is there a timeout? And Calvin's asking, in case there are a lot of memory block changes on the VM.
Ultimately, there is a timeout period of 2 minutes.
2 minutes.
Okay.
So, good. I think the answer might be no to this one. David said, can you show us a ping of the VM being moved?
I can move it back and do a ping if we've got time. That's fine. It's just ultimately
we've got about 5 minutes. Ultimately, we might not have time for that.
Okay, we'll see how we get on with the couple of bits we've got left to talk about.
Yeah. Yes.
But it would have just lost one ping.
It would have. Yes. You have to trust us that it's just lost. It's just lost one ping.
Actually, on my YouTube channel, where there'll be a link for coming up shortly, there's a video on my YouTube channel, and I'm doing a similar demonstration, and I'm doing ping, so you can watch my YouTube video. That would be a way to address that.
That's a great way to solve it, isn't it? Yes,
Yeah.
and we will give those details at the end.
Yeah.
So do go and see Paul's YouTube channel, because there's a ton of extra stuff there, isn't it? Yeah, and I was going to say. So what percentage of resources lost when running a full installer server 2012 as the hypervisor, as opposed to something more lightweight, for instance, ESXi? I don't know what that is.
That's sort of VMware.
Yeah.
Again, to be honest, as I've sort of really just highlighted in terms of the customer that I worked with in terms of very little really. It's about workloads. One of the mistakes obviously a lot of people make with products like HyperV is they actually use the physical host for other activities as well, because it's a Windows machine.
Yes.
And actually, if you was to ring fence it and treat it the way you should, you'd actually find performance today is comparable. If you wanted scenarios where I would say that ESX and VMware would be better, would actually be better at legacy versions of Windows and Linux and Unix ports, where Hyper-V is more than likely better at the latest versions of Windows because of the integration with the OS and Hyper-V.
Does this feature enhance disaster recovery, as opposed to having a sort of a VM ready to kick in?
It doesn't really enhance disaster recovery, because live migration, same as vMotion, is a planned activity.
Yeah.
So it doesn't implement that. Obviously, one of the choices on the poll is to do a session on Hyper-V Replica, which does enhance high availability. And so obviously you might want to select that on the poll.
I am so glad you are helping me. Do not forget to select on the poll what you want to see next, especially if you've enjoyed this and you want some more of it, where you can get exactly what you want more of if you vote, but only if you vote for it. If you don't vote, you can't complain if you don't vote.
Exactly, yep.
Exactly. We've only got a few minutes left, so should we do the wrap-up on where there's extra material, and if we've got time for just a couple of wrap-up questions.
Okay,
that's
no
fine.
problems.
Yeah.
Okay, so really, as you'd expect, there's always the hook at the end. So
you've earned it. You've earned it, mate.
So effectively, to ensure that I keep getting paid, as part of attending this, there is going to be effectively some promotions from the organisation that I work for, QA. So on the special offers tab that you've got in the client, there should be a couple of links, which again I'll show you in a second, which will take you through to some Microsoft pages, and on there are some course offerings. So really, from our point of view, and also I guess from Microsoft's, there's a bit of a call to action for people that might want to go out there and actually do some proper Windows Server 2012 training, obviously some Hyper-V training. Now, just from the point of view of QA, we've got some unique offerings which might be of interest to you. So first of all, I believe we have a unique offering for people that have got good 2000, 2003 skills to upskill them straight to 2012, whereas Microsoft don't have an offering in that space. Them offerings are either you don't know what Windows is, or you've got good 2008 R2 skills. Plus, we've also got a unique course offering, which is a dedicated, deep technical Hyper-V free course, which again is unique to us. So there is some special offers on those.
These are longer things, because one of our problems with this was to think, what can we tell them in an hour?
Exactly,
isn't it?
absolutely.
There's such a lot to go through. They get a full day of you.
Obviously, depending which course, the Hyper-V free would be 3 days of me. So, and obviously the Microsoft course is, up to 5, depending what course it is. And we've got a lot of discounts running alongside those. So look at those offers, reduced pricing, and also free exam vouchers as part of the offers as well. And if we've got any international audience, so for example Trevor, if you're interested in this, we also have a model called Extended Classrooms.
You can't teach Trevor anything.
True, yes. But actually, if you're not UK based, you can still buy the training at the discounted price, and we can teach it to you where you sit.
Okay.
Anywhere in the world.
Yes.
So that's just the sort of slide that contains the URL, but that's on your offers page anyway, so I'm going to skip over that. And as I did promise people my email address and bits and pieces along those lines, then they're on the slide, so hopefully you can see those, and I'll leave that up there for you.
So that's it. And so, on your YouTube, you produce little films,
little video,
demonstrate some of the things that we haven't had time, and also in other areas.
Yeah, certainly. And there'll be quite a lot going up on there quite shortly, actually, around System Center as well. So, especially Orchestrator, Microsoft's best kept secret.
Aha. Okay. Well, is that on our poll?
It's not. No. It's not Windows Server 2012, unfortunately.
Of course, that's it. Yeah, you're gonna have to get a YouTube for that one. But please come back. We've run out of time. This is all of your time that we have for today, which is a real shame. But I think we've still got questions coming in here, so we'll try and deal with those questions offline if we can, maybe in an article, or maybe if there's something like that, but we will to pay attention. Please let us know what you thought of this. Please vote in the poll. Please come back again when we do another one, because we'll have Paul back in the studio. You've worked very hard today.
Oh, thank you very much.
You take a break after this, and thank you for watching. And from the Register, my name's been Tim Phillips. Goodbye.
Goodbye.